This video is dedicated to just one question, and this is question 5 on page 311. I avoided question 4 because I hated the layout of the table. That table in question 4, if you want to look at it, is long, it's painful, and you're not given these lead-ins in an exam. You're just given a table with X's, and you might have to work out a few Y's, but you won't be given all that help, so I'm not giving it to you either. Now, having said that, it says copy and complete the table of values for the cubic function y equals x cubed plus, please note, x cubed plus 4 squared minus x minus 4 for values from minus 6 to 1. And there's the table, minus 6 all the way up to 1, going up in 1 unit. And I've calculated these myself to save time on the video. There's no point in you watching me do this. Mind you, I did do one of them. Now look, you know I like doing the table working down rather than going across. So here I go. I substituted minus 6 into the equation. So it's open my bracket, I went minus 6, close the bracket, cubed, plus 4 lots of minus 6 in bracket, then squared, then minus, open my bracket, minus 6, close the bracket, and then take away the 4 as it says there. And I calculated my y value to be minus 70, there it is there, hence I've got coordinate minus 6, minus 70, and that's why I've got the minus 70 up there. Alright? Expect these numbers to be big and wild, because obviously we're cubing things, and if you start to cube things, it's going to get quite big quite quickly. I mean, think of 4. 4 times 4, 16. Times 4 again, 64. Already, 4 to the power of 3 is 64. So we're getting quite big. So that's why some of these can be quite wild and wacky. So there it is. So I've done all these things again. Now, what I did was I actually drew the graph going up to, you know, where x values 1 and y was calculated 0. I actually did this coordinate as well, where x was 2, and I calculated the y value to be 18. Now I did that for a reason, because when I plotted the graph on the other page, which I'll show you in a moment, you couldn't quite appreciate the lovely curvy nature of the x cubed type graph. Alright, so you remember these are x cubed type. They have this sort of kink in them, or they could be like sort of double humped like that, etc. Alright, so because I didn't like what was happening at that end there, I wanted to just do one more calculation, and so I'm going to stick it on the table there, and that's why it's down there. So I went 2 cubed plus 4 lots of 2 squared, because x is 2 this time, take away 2, because it says take away the x value, and then take away 4, and I've got the coordinate 218, and I've plotted that on the graph. So when you come to do this in the exam, say, it's safe. I recommend you do it like this, but they won't give you a completely blank table. Again, like I said, you get some x values here, all the x values given to you, and there may be just like, say, 2 y values that you've got to calculate, and you get 2 marks. They give you the rest of it. So I set about calculating these ones, and I plotted it. So let's draw the graph of that. Can't bother to read all that, and bam. I think that's beautiful. Now, had I not, I mean, just look at it, that's just stunning. Look at that. I missed it there, never mind, allow me. It's a lovely, curvy, beautiful x cubed type graph. And I ain't got space to write the equation, so I'm not going to mess up my handiwork, am I? Now look, had I stopped there at the point 1, 0, you wouldn't appreciate the upturn, so to speak, on the graph. So I want you to appreciate that though the x cubed graph given to you was complicated, had a complicated equation, it still had the up, down, up type characteristic features. And look, there's a turning point there, and up it goes again. It's really, really lovely. And I wanted you to see it in all this glory. Right, so that's me plotting the graph. Again, you can all plot coordinates. I'm not going to teach you how to go left, right, up, down. Now, use the graph to solve these equations. We've got the same basic equation there. So y equals x cubed plus 4x squared minus x minus 4, and also to make it equal to 0, I've got to draw in the line y equals 0. Now I wonder where y equals 0 is. Right here. You know the x-axis is y equals 0. And look, I see 3 solutions. I know I've missed it there, but look, it's minus 4, minus 1, and 1. So these are the 3 solutions then. So let's go in red. So I've got x equals minus 4. Besides, look, there's line y equals 0 crossing a minus 4 on the x, and there's the other one. It's there, isn't it? Don't need all that. So x equals minus 4, minus 1, and where's the other one gone? There it is, 1. Let's just check that I've made a mistake. So even lifting it straight off the graph, off the table rather, when y equals 0, x equals minus 4. When y equals 0, x equals minus 1. When y equals 0, x equals 1. Let's just look at it on the diagram itself, the graph. Minus 4, yeah, that's where they cross. Minus 1, that's where they cross. And 1. Let's just highlight it there, there, and there. Alright, 3 solutions. Going back again, we now have to solve x squared plus 4x squared minus x minus 4 equals minus 12. In other words, y equals this equation, and y has to equal minus 12 in order for there to be a solution. In other words, plot the line y equals minus 12. We get the x answers in a minute. Let's just take a look. Minus 12. Well, to use a red line now. Well, there's minus 10. Minus 12 will be about, let's have a look. There, second line down. Oh, that's nice. I like it. Alright, so that's my line y equals minus 12. As you can see, there's just one solution right there. Let's try and read up. Quite difficult for me there. There you go, right there. Oh, actually easy to read because every square is worth 0.1 of a unit. So that's minus 4.4. That's minus 4.6. So here I go. X equals minus 4.6 as a solution where the graph crosses the line y equals minus 12. That's a little bit better, I think. Anything else? No, that was it. Alright, so is this difficult? No, except this time you're not given a graph. You have to finish off a table of values. You've got to create the y values, the ones that are missing. In this case, there are 1, 2, 3, 4, 5, 6 of them. You will never be asked to do that many in an exam, it just takes too long. Maybe 2 maximum, no more. I've ever seen more than that come up. So that's been done. Then you draw the graph, that'll be worth a couple of marks. Then you solve a couple of very basic equations, y equals 0, y equals minus 12, and there are the solutions shown there. That's for the line y equals 0, the x-axis. That's the line y equals minus 12, and it's just one solution. And that's it so far. And I'll stop the video now because now we're going to move on to 21.2, reciprocal functions. And that's the reciprocal function that should have been in the title on page, well, the beginning of chapter 21, but it wasn't there. Maybe they thought it was too long or something. But anyway, it's got its own section, reciprocal functions, and that's coming up quite soon.